Hello everyone, my name is Vimal Datt and I am working as an assistant professor in IIMT College of Pharmacy. Today I am going to discuss about a very common topic, that is filtration. So we are moving to the next slide. Here we cover some content, that is introduction, what is filtration, why we do filtration and how it is done. And then techniques used in filtration. So what is filtration? It may be defined as a process of separation of solid from a fluid by passing a sieve through a porous medium that retains the solid but allow the fluid to pass through. So this is the common definition, or we can say it is a common process by which we can separate our solid from any liquid mixtures. And then this is it is a common assembly used for filtration. Here, first of all, we use glass funnel as a support, and then filter paper for as a filter medium, and then solid residue which is collected over the filter paper, and then lastly the filter, that is the clear liquid obtained after the filtration. So it is a basic assembly. It is commonly used in our laboratory on small scales, and this process is also used in our domestic purpose, such as separation of any solid from our mixture, like separation of paneer from the milk, and then basic terms used in filtration. So first of all, that is slurry. Slurry is basically suspension to be filtered, and then filter medium. Any porous medium used to retain the solid is known as filter medium, and then filter cake. Filter cake is the accumulation of retained solid on the filter paper, or we can say the solid part collected over the filter medium. And then lastly, the filtrate, that is clear liquid after passing through the filter paper or filter medium. So these are the some basic terms commonly used in the filtration process. And then why we do filtration? This is the main question. That is, so here we discuss why we do filtration. First of all, production of sterile product. Filters or laminar air vents provide sterile environment during manufacture of sterile product. Bacteria proof filters are used for the filtration of thermolabile substance where heat sterilization is not applicable. Production of bulk drugs. Filtration is an essential step in the removal of impurities from the product. And then production of liquid orals. Filtration is very important in the production of liquid orals and the other for obtaining clear solution. Example in aromatic water filtration, syrups, elixirs, and eye drops, where removal of foreign impurities is very important. And then lastly, the effluent and waste water treatment. So these are the things in which we use filtration. So if we talk about in a layman language, if you are buying any injection, so you will not, अगर हम नॉर्मल बात करें तो कोई भी हम में से नहीं चाहता कि उसके प्रोडक्ट के अंदर कोई भी फॉरेन पार्टिकल, आपका अनवांटेड पार्टिकल या फिर इम्प्योरिटी उसके अंदर हो, प्रेजेंट हो। तो इस चीज को दूर करने के लिए या प्रिवेंट करने के लिए हम यूज करते हैं फिल्ट्रेशन का, जिसके जिसके माध्यम से हम अपनी इम्प्योरिटीज को सेपरेट कर लेते हैं फ्रॉम आवर सॉल्यूशंस। देन दिस इज द बेसिक कॉन्सेप्ट ऑफ फिल्ट्रेशन। I'm moving to the next slide. Process of filtration. So first step is pores of filter medium are smaller than size of particle to be separated. This is the most important thing we have to consider in the process of filtration. So if the pores of the filter medium are larger in size than the particle size of our solid material, So filtration is not be done. Filtration cannot be done. So we have to choose some filter medium that have the smaller size pore size than the particles. So second step is filter medium. Filter paper is placed on a support, that is mesh, and then third slurry is placed over the filter medium. Fourth step is due to the pressure difference across the filter paper, fluid flows through the filter medium, and then gravity is acting over the filter medium. So gravity is responsible for the filtration. It will work as a driving force for the filtration process. So and the last process is sixth step is, so solids are trapped on the surface on the filter medium. And then I'm moving to the next slide, that is mechanism of filtration. The mechanism whereby particles are retained by a filter is significant only in initial stages of filtration. First, first point is staining. Similar to sieving, that is, the particle of larger size cannot pass through the smaller pore size of the filter medium. Second is entanglement. Solid having the momentum move along the path of streamline flow and strike on the filter medium. Thus, the solid are retained on the filter medium. Third one is impingement. Particles become entangled in the mass of fiber of cloth with a fine hairy surface or porous felt. Porous felt. Due to the smaller size of particle than the pore size, thus the solids are retained on the filter medium. Last mechanism is attractive forces. Solids are retained on the filter medium as a result of attractive forces between particles and filter medium, as in case of electrostatic precipitation. In practice, filtration may combine various mechanisms. So these are the basic mechanisms used involved in the filtration process. So first of all, it's streaming. Staining is a common process in which we just sieve our product with the help of mesh or any filter medium, in which the particles of larger size can retain over the filter medium. Second one is entanglement. So entanglement uh, basically is a process of sticking between the pores of the filter medium. And then impingement. Impingement is mass in this the particles is stuck in the hairy structure or fibers of the filter medium. And then lastly is the attractive force. These are the common mechanisms used in the filtration. And then types of filtration. So here are two types of filtration. That is, first one is surface or screen filtration. Second one is depth filtration. So screen filtration, it is a screening action by which pores or holes of medium prevent the passage of solid. Mechanism involved is straining and impingement. For this, plates with holes or woven sieves are used. Efficacy is defined in terms of mean or maximum pore size. So basically, it is a common process in which we will just use our filter paper that is having the smaller pore size than the particles of our solid. And then second one is depth filtration. In this, the slurry penetrates to a point where the diameter of a solid particle diameter of a solid particle is greater than that of the torus void or channel. Mechanism entanglement. The solids are retained with a gradient density structure by physical restriction or by adsorption process of a medium. So in this process, the particles just pass through the filter medium and stick in the holes, and then it shrinks the size of our filter medium. by entangling in within the pores or capillaries. And then theories of filtration. So here are some theories of filtration. The first one is rate of filtration. The flow of liquid through a filter follows basic rules that govern the flow of any liquid through the medium offering resistance. Second one is rate of flow may be expressed as rate is equal to driving force divided by resistance. So what is driving force? Driving force, the pressure difference between the upstream and downstream of the filter. Second is rate of filtration expressed as volume liter per unit time, dV by dt. And third one is resistance. Resistance increases with an increase in the deposition of solid on the filter core. So as much as our solid is retained on the filter core, it will increase the resistance over the filter medium. Hence, the rate will be high in the beginning of filtration because resistance is minimum, and it will be less at the end of filtration. Once the filter cake is formed, its surface acts as a filter medium and solids continuously depositing adding to the thickness of cake. Resistance to movement is equal to pressure upstream minus pressure downstream divided by length of capillary. So by this equation we can calculate our resistance of movement. And then theories of filtration. Theories of filtration is based upon three equations. First one is Poiseuille equation, Darcy's equation, and Poiseuille-Karman equation. So in this slide, we will discuss these equations separately. First of all, we discuss about Poiseuille equation. Poiseuille considered that filtration is similar to the streamline flow of a liquid under pressure through capillaries. He expressed equation here that is V is equal to pi delta P R T Q R R4 divided by 8 L mu. In this equation, V denotes the rate of flow, that is volume of liquid flowing in unit time, that expressed in meter cube per second, liter per second. And then delta P is pressure difference across the filter paper. And then R is the radius of capillary in the filter bed. And L is the thickness of filter capillary length. And N is the viscosity, mu is the viscosity of the filtrate, calculated in Pascal. If the cake is composed of a bulky mass of particles and the liquid flows through the interstices correspond to a multiplicity of capillary tubes, then the flow of liquid through these may be expressed by Poiseuille equation. Second one is Darcy equation. So Poiseuille equation assumes that the capillary found in the filter are highly irregular and uniform. If the length of capillary is taken as thickness of the bed, a correction factor for radius is applied so that rate of reaction is closely simplified. The factor influencing the rate of filtration has been incorporated into an equation by Darcy, which is V is equal to K delta P upon mu L. K is the permeability coefficient of the cake, and then A is surface area of the porous bed, that is filter medium. And then the term K depend on characteristics of the cake such as porosity, specific surface area, and compressibility. Permeability is the flow rate of liquid of unit viscosity across a unit area of cake having unit thickness under a pressure gradient of unity. This model not only relates to filter beds or cakes, but also applies to other types of depth filter. This equation is valid for liquids flowing through sand, glass, beds, and various porous media. Further, modified by including characteristics of K by Poisson-Carnot equation. So this equation is further modified that after known as Poisson-Carnot equation. So Poisson equation is made applicable to porous bed based on the capillary type structure by including additional parameters. Thus, the resultant equation is V is equal to A divided by nu S square into delta P divided by Km into epsilon divided by 1 by epsilon ka 1 minus epsilon ka square, in which epsilon is the porosity of the cake, that is filter bed. Second, S is specific surface area of the particles corresponding to cake. K is Poisson constant and the K is usually taken as 5. The effect of compressibility of the cake on flow rate can be appreciated from the equation 1, since the flow rate is proportional to epsilon cube upon 1 minus epsilon ka whole square. A 10% change in porosity can produce almost threefold change in V. Means a 10% change in porosity. If we increase the porosity of filter mediums is up to 10%, it will result in threefold change in V, means flow rate. Yeah, rate of filtration. If we increase the porosity of the filter medium, it will proportionally increase the rate of filtration. So, limitation of Poisson-Carnot equation is it does not take account of the fact that the depth of a granular bed is lesser than the actual path traversed by fluid. The actual path is not straight throughout the bed, but it is sinus and rotors. So, it is a limitation of the Poisson-Carnot equation. Factor influencing filtration. The particles are exposed to a number of forces including gravity or electrical fields. Some of the factors influencing the filtration are properties of fluid, density, viscosity, and corrosiveness. Second is properties of the solid particles, shape, particle size, particle charge, density, particle size distribution, rigidity, or compressibility of the solid under pressure, and tendency of particles to flocculate or adhere together. Third is proportion of solids in the slurry, rate at which filter cake is formed, especially in the early stages of filtration. Objective: whether the solid or liquids or both are to be collected. Temperature of the suspension. So these are some factors that influence the rate of filtration, such as properties of fluids. Density: highly dense solid will stick on the will fast stick on the filter bed, and then viscous fluid. Viscous slurry will take some more time for the filtration, and then particle shape, particle with irregular shapes takes more time for the filtration. So these are some basic factors that will influence the rate of filtration. Classification of filtration equipment. First is pressure filter, second is vacuum filter, third one is centrifugal filter. So first one is pressure filtration. The driving force for a filtration is the pressure difference. Pressure filters are used in conditions like due to the formation of cake of low permeability. Many types of slurry require higher pressure difference for effective filtration. So, if we apply a pressure in normal filtration process. So it will fast the filter rate of filtration. So this process is known as pressure filtration. The filtration rate depends on type of slurry. The rate increases with the increase of pressure. As we increase the pressure, it will directly increase the rate of filtration. Example, plate and frame filter press and filter press. Plate and frame filter press. Principle of this process is the mechanism is surface filtration. Slurry enter the flame by pressure and flow through the filter medium. The filtrate is collected on the plates and sent to the outlet. A number of frames and plates are used so that surface area increases and consequently large volumes of slurry can be processed simultaneously with or without washing. So by this process, we can separate or filter a huge amount of slurry, or we can directly increase our rate of filtration by increasing the number of plates or frame in the machine in this equipment. This is the construction of this filtration equipment, that is the construction of a plate and filter frame filter press is shown in figure. The filter press is made of two types of unit, plates and frame, usually made up of aluminum alloy. These are also lacquered for protection against corrosive chemicals and made suitable for steam sterilization. Frames contain an open space inside wherein the slurry reservoir is maintained for filtration and in an inlet to receive the slurry. Plate has a sudden and or grooved surface to support the filter rod and an outlet. Plate, filter medium, frame, filter medium, and plates are arranged in a sequence and clamped to a supporting surface. So this is the equipment. In this, we can see this is the filter cloth, and this is the frame, and this structure which have irregular surface is plate, which support our filter cloth or filter medium. So basically, we input the our slurry into this machine and apply a pressure. After that, the filtrate will be collected in the filter will be collected in the reservoir. So I am moving to the next slide. Here, so it is a basic structure of uh, our pressure filtration machine. This is the clamping pressure, and this is the filter media. These are the plates with the irregular surfaces, and this is the frame which provide the support for in the equipment of machine. So this is the slurry inlet, and this is our filtrate outlet. So here I am discussing about working of this machine. The slurry enters the frame from the feed channel. The filtrate passes through the filter medium on the surface of the plate, while the solid form of filter cake in the frame. The filtrate then drains down the surface of the plate between the projection on the surface and escapes from the outlet. Filtration is continued until the frame is filled with filter cake. When the process is stopped, the frame emptied and the cycle is reached. Channels for the slurry inlet and the filtered outlet can be arranged by fitting eyes to the plates and frames. This has the advantage that the filtrate from each plate can be seen and In the event of a broken cloth, the faulty plate can be isolated and filtration continued with other plate less, with one plate less. The thickness of the cake can be varied by using frames of different thickness, and in general, there will be an optimum thickness of filter cake for any slurry depending on the solid content of the slurry and the resistance of the filter cake. As filtration proceeds, the resistance of filter cake increases and the filtration rate will be decreasing. At a certain point, it will be preferable in terms of the overall output of the process to stop and empty the press rather than to continue filtration at a very low flow rate. Advantage. Advantages are construction is very simple and wide variety of material can be filtered. It provides a large filtering area in a relatively small floor surface. It is a versatile, the capacity being variable according to the thickness of the frame and the number of plates used. The construction permits the use of considerable pressure difference. Efficient washing of the cake is possible. Operation and maintenance is straightforward and there because there are no moving parts. Filter cloths are easily renewable and because all joints are external, any leaks are visible and do not contaminate the filtrate. Disadvantage of this process is the filter press is an expensive filter. The emptying time, the labor involved, and the wear and tear on the cloth resulting in high cost. Operation is critical as the frame should be full, otherwise washing is inefficient and the cake is difficult to remove. The filter press is used for slurry containing less about 5% solid. In view of the high labor cost, it is more suitable for expensive material. Example, removal of precipitated protein from insulin liquids. Second one is vacuum filtration. Vacuum filtration is used primarily to collect a desired solid. It uses a Buckner funnel and a side arm flask. It is faster than gravity filtration as the solvent or solution and air is forced through the filter paper by the application of reduced pressure. Wide scale application in chemical, food, and pharmaceutical industry. Example is rotary drum filter. So, rotary drum filter. The rotary drum filter is continuous in operation and has a system for removing the cake that is formed. It is suitable for use with concentrated slurry. It is a metal cylinder mounted horizontally. The curved surface for being a perforated plate supporting a filter top. Internally, it is divided into several sectors and a separate connection is made between each sector and a special rotary wall. In addition, compression, drying, and removing filter cake are possible. So this is the machine rotary drum filter in which we apply feed. We apply feed of it, or we can say slurry. Here, this is the cake formation zone. As the drum rise, it takes the slurry over the filter medium, and this is the washing zone, and this is the vacuum or deliquoring zone in which the vacuum is applied to separate the liquid or filtrate. After that, lastly, the knife is attached to separate a filter cake or cake discharge. So this is the working of rotary drum filter. The drum is dipped into the slurry and vacuum is applied to the outlet, which is connected to the filtrate receiver. When the cake has formed, the cake drained or partially dried by vacuum. The drum is sprayed with water to wash the cake, retain the vacuum connection, drains the cake and produces partial dryness, then remove by a doctor knife. When the solid of slurry are too much, that the filter cloth becomes blocked with the particle. A pre-coat filter may be used. A pre-coat of filter air is deposited on the drum prior to the filtration process. Here we can see the whole process. Uh, these are the suction pumps which are connected to a vacuum pump, and then this is the slurry in which our drum is dipped. After that, a cake is formed over the drum, and then washing is applied on over the drum to wash the slurry. And this is the dewatering zone. Dewatering zone to remove the solvent or filtrate. And then this is the knife, doctor knife to collect to separate the solid or filter cake from the drum. So here are the advantages. The rotary filter is automatic and is continuous in operation so that the labor costs are valuable. The filter has a large capacity, so it is suitable for the filtration of highly concentrated solution. Third one is variation of the speed of rotation enable the cake thickness to be controlled. If you fast the rotation of the drum, the filter cake is formed with less thickness, or if we slow down the rotation of the drum, the filter cake form is in high thickness. And then fourth one is pre-coat of filter aid could be used to accelerate the filtration rate. Disadvantage of rotary drum filter is the rotary filter is a complex piece of equipment with a many moving parts and is a very expensive. In addition to the filter itself, some accessories are connected. Example, a vacuum pump, vacuum receivers, slurry pump, and agitator are required. The cake tends to crack due to the air drawn through by vacuum system, so that washing and drying are not efficient. Being a vacuum filter, the pressure difference is limited to 1 bar and hot filtered may boil. It is suitable only for straightforward slurries. Last one is centrifugal filtration. The driving force used is centrifugal force. A centrifuge consists of a basket in which mixture of solid and liquid or mixture of two liquids is rotated at high speed so that it is separated into its constituents by a action of centrifugal force. Type of basket. Type A basket is imperforated, in which the liquid is removed through a steaming tube while the solid particle sediment to the wall. In pharmacy, the centrifuge is commonly used for drying crystals and for separating emulsions into their constituent liquids. B. Perforated basket, in which the liquid passes out through the holes. Perforated basket centrifuge, a vessel about 1 meter in diameter and its outer wall is perforated. It is mounted on a vertical shaft by means it can be rotated at a high speed. An outer casing with an outlet collects the liquid thrown out from the basket. Rotation speed is 20 to 25 rotation per second. So this is the basic diagram of perforated basket centrifuge filtration equipment. In this, it is the filter probe. This is the mounting shaft, and this is the perforated basket. If we rotate this basket, the slurry is filled in this container. If we rotate this basket, the slurry will move towards the external surface of the drum. After that, it will stick to the filter medium and the filtrate or solvent is moved out from the drum with the help of pores or perforated holes in the basket. Working of this machine, the feed is introduced through the centrally located basket funnel, and the cake is formed in the space between the flange and the vertical base of the basket. A reciprocating cushion disc moves the formed cake along the surface of the basket, freeing the surface for further cake deposition. The cushion makes one stroke forward and backward until a further layer of solid is built up, where a second stroke follows, and so on. The filtrate passes through the holes of the basket and is collected by suitable piping. In a second stage, a washing spray is admitted by a perforated head. In a third stage, drainage and partial drying of the cake takes place after which the dry solid may be automatically collected. Advantage of this process is it is very compact, occupying very little floor space. Second is it is capable of handling slurries with high proportions of solid. Third one is the final product has generally a very low moisture content if compared to a filter cake of a similar material. Disadvantage of this process is batch process, and it involves a considerable labor cost, making the process very expensive. So this is all about the filtration process. Its machines, its and various factors influencing the filtration and various theories involved in the filtration. So here I am stopping my presentation. Thank you.